Welcome, ladies and gentlemen. My name is Algonda Lagrange, and I'm Director for Digital Solutions with Siemens Energy, where I focus on the oil and gas industry. Firstly, I would like to thank ONS for giving Siemens Energy the opportunity to participate here and for ONS's efforts in hosting this virtual event in such a difficult time. So let's get to the topic of our discussion today, and that is how a major gas compression station project reduced cost, risk, and time to maximize their investment returns. Now, this is a very relevant topic because the demand for gas as part of the transition in the energy landscape is driving a lot of investment in transportation infrastructure. And these projects are complex, they're high risk, and a new greenfields facility takes typically 2 to 3 years from feed to startup. Customers need to streamline the process of bringing new compressor stations online. Of course, they also want to reduce OpEx, but that's a topic for another discussion. So how is Siemens able to deliver this? And the difference lies in OEM rather than EPC-centered design and delivery, and then in using the value of the digital twin that we deliver right out of the box. Now, for compressor stations, the rotating equipment, the electrical packages, and the ICSs make up a very large proportion of the scope. And this is scope that the OEM is really best suited to design and deliver. So rather than having an EPC as interface between the customer and the OEM, our approach is for the OEM to take responsibility for the delivery of their scope, or in some cases, for the complete project. Now, this means that the compression drivetrains with a compressor and gas turbines arrive from factories as fully integrated and tested modules that uses a plug-and-play installation with the utility and off-site systems to reduce on-site work and associated schedule interdependencies. It also means that the delivery of the control and safety systems becomes pre-integrated into the overall scope. And this, of course, simplifies interface management by enabling one point of contact with a customer for a very large or then the complete project scope. Now, let's step from here to the digital twin. Um, the underlying requirement for a digital twin is data persistence. It doesn't necessarily have to be a single database, but all of the data should exist once as the master and should be made available to the various applications that would use that data to deliver value. And here I'm talking about 3D, 2D, and 1D engineering data, time series data that gets generated during the ops and maintenance phases, as well as event data or unstructured data associated with maintenance. This data needs to exist all the way from the concept and feed phase, and then need to flow into operate and maintain so that the data backbone of the digital twin is solid. But data alone doesn't deliver the value. You also need applications. The first class of applications is what I call the plant twin. This is taking the standard 3D CAD model and making it available for non-CAD users to do things like construction planning or training of your field operators, or planning your evacuation routes in case of an emergency. Also, as you move forward towards unmanned operations, the plant twin becomes more and more important. The second category is process twin. This is a dynamic process model of the plant that is integrated with a control system that is used for testing your automation configuration, for training your operators before startup, and during operations for running multiple what-if scenarios. Now, these applications can run either on the cloud or on the edge, depending on the customer's preference. During the operate and maintain phase, You then expand the number of applications with the performance twin and with OEM services. Now, the performance twin is automated diagnostics of the performance of the overall facility, whereas OEM services provide operators with fleet-wide insights into the more complex critical equipment. And this is really important because at the state of technology we have today, we cannot yet replicate all the experience that reside within our experts in automated algorithms. So experts is still very much part of the solution. A project where we have proven this approach is the Wheeler, which was delivered in 2017 to Gasco. And you will see there that the scope of supply is much broader than what it would have been for a standard OEM delivery. And in fact, Siemens here acted as the EPC. And the benefit that we were able to deliver for the customer was huge, with first gas achieved within 16 months, whereas the FEED study that assumed a traditional delivery approach estimated 26 months. So, in conclusion, then, Tawila is a really good example of how value can be realized with an integrated delivery of compression trains. The OEM centered execution approach greatly simplifies interfacing, and it opens up the opportunity to use digital to drive value both during the project phase as well as during operations and maintenance. This approach leads to an overall reduction in the total cost of ownership and higher profitability for our customers in a low price gas environment. Thank you.